Hello. We have already mentioned the computational conception of cognition. Today we're going to dig deeper into the notion of computation that is behind classical computationalism about the mind. And to do this, we're going to follow John Haugeland's influential elaboration of the notion of a computer, as a way of answering the question, what is a computer, such that a mind could be one? Computationalism about the mind begins with an apparently simple proposal. The proposal is that thought is computation, or can be understood as such. This is a view that has been in the air at least since the 16th century, when Thomas Hobbes wrote in his book The Leviathan that explicit reasoning is, in the end, a mechanical operation, like adding or subtracting with an abacus. Reasoning is nothing but reckoning, he said. That is, reasoning is calculating. So when you're thinking, according to Hobbes, you're carrying out an internal discourse. You're carrying out a symbolic activity, such as writing or reading, and moreover, that activity involves manipulating symbols according to rules. Later, this hypothesis became the idea that intelligence and cognition in general involves information processing. This hypothesis was combined in the mid-20th century with the availability of digital computing machines and the development of a theory of computation by people like Turing and Church. The connection went like this. As we said, it was hypothesized that cognition involves processing information. And processing information is precisely what computers do, by manipulating symbols. Okay, so far so good. So we have the hypothesis that thought can be fruitfully seen as computation. But this hypothesis is not going to be very informative until we are told more about what computation is supposed to be. That means that we need a more or less worked out characterization of the notions of computation and of a computer. Now, given that the project is to model minds as computers, this characterization must be, first, abstract and general enough to encompass both biologically based minds and, say, commercial electronic computers, and also it must be concrete and specific enough to be informative. Now, at the outset, let me distinguish two different projects, which may or may not be carried out in tandem. The first one concerns technology, first and foremost. And it is the engineering task of trying to make machines that think, regardless of whether that throws light on how humans actually process information. This is what some AI people have tried to do. The other one is the general scientific project of understanding minds in terms of computation, regardless of whether this means that thinking electronic machines are feasible in any practical sense. In any case, both tasks rest on the assumption that cognition involves computation. They are also compatible with the assumption that we, natural thinkers, are computers in some respects, I hasten to add, because computationalism is compatible with the view that some aspects of cognition may not be computational. So, how can we go from mere computing, which is a mechanical process if there ever was one, to something that we can call thinking? How could thinking occur in a computing system? Well, here's one way this could go. We know that computers can perform operations on tokens, say sequences of states that can be modeled as zeros and ones. Now, if, and this is an important if we can arrange for those tokens to be symbols, some of which may be representations in the sense of standing for something else, and if we can constrain the symbols' manipulations so that they proceed rationally, as thought is ideally said to do, then it will be possible to have a thinking machine, or rather, we will have cognition arising from a computational system, since that system will represent the world and will exhibit rationality. So it would be possible, in that case, to synthesize a mind, as it were, and then to understand mentality. Of course, I've just thrown around heavily loaded words like rationality and representation, but these are taken to be some of the characteristics of the human mind, and I'll have something more to say about them later. Well, that is a sneak preview of what's coming. But let's go back to the problem we have posed, namely, to work out a notion of computation that's appropriate for a given content to the hypothesis that thinking is computing. And that's the task for our next video. Bye. Cheers.